Hey guys, welcome to day 2 of College Algebra. First thing I wanted to point out, there's been some confusion and I should make sure to clarify this fully. All assignments for my class are typically due on Fridays. You have the entire week to work on them. The reason being is if we're going to offer assistance on only Tuesdays and Thursdays, if I offer something that is due on Monday, then you'll never get help on it, and that seems unfair. And so all assignments for each week will be due on on Friday, usually at noon. This will give you a full 24 hours for almost every assignment at the very least. And so that should give you enough time to work on them. And I do try to make sure my assignments are of the appropriate length, that they don't interfere with your normal schedule. So do note anytime we talk about these kinds of problems, if for some reason an issue comes up, let me know. I'm more than happy to work around those things. And I'd rather spend time working around them than the alternative, where I have people who are not getting the information they need and therefore feel like this program is not fulfilling what they need for the summer to prepare them for next year. That would be, in my opinion, the greatest failing if that happened. And so please, at any point in time, if you feel that something needs to be changed or something needs to be adjusted, let me know. I'm more than happy to work around that kind of stuff. Okay, so we got only a small list of things to do today. Last time we went over time, so that today I'm going to try to go under. Let's see how we do. Let's get started. For today, we're going to focus upon 3 major topics. We're going to talk about evaluating something, simplifying via variables, and then solving with single variables. All, again, basic stuff. We were supposed to start off with the basics to prepare us for future material, so let's see how we do. Okay, so let's start off by talking about evaluating. Now, evaluating can be seen in 2 senses. The first sense is when you have an algebraic expression, and the second sense is when you have an algebraic equation. So an expression means there is no equal sign, whereas an equation means there is an equal sign. So an example of an algebraic expression would be something like 11 minus 3y. An example of an equation would be something like 5x plus 2 equals y. This is an equation. An expression is one that has no equal sign. An equation is one that has an equal sign. And evaluating can be done in both circumstances. Now, the term evaluating, or evaluate as it's typically referred to, just means to plug in, or the fancy way, substitute for an unknown. The idea here is, in algebra, what separates algebra from arithmetic, as we talked about last time, algebra employs the use of a variable. So x's, y's, z's, Greek letters, anything you want. And so you can make a variable out of anything, and it's just considered to be an unknown value. It is common in mathematics to talk about evaluating, meaning that the unknown becomes known, and therefore can be used to determine something. So let's take a look at this top expression, 11 minus 3y, and ask a series of questions. How would I evaluate in the following 3 circumstances? First one, what if I evaluated when y equals 2? What if I evaluated, second one, when y equals 0? And what if I evaluated when y equals 2/3? Well, the term evaluate just means to plug in or substitute in for something else. So in this case, I take my expression, 11 minus 3y, and everywhere there used to be a y, I can replace it with a 2, or a 0, or a 2/3. Now you'll notice when I do this step, I do not use an equal sign here. Because there is no equal sign in the problem, I don't want to put one in and turn this into an equation. So I'm going to use my little therefore symbols. So this top one, if I take 2 and plug it in for y everywhere there used to be a y, I could then do my order of operations. I would do the multiplication part of this first, since there's nothing to do in the parentheses. So 3 times 2 would be 6, and then 11 minus 6 would of course be 5. Same thing in the second piece. 11 minus 3 times 0. The 0 is in parentheses. I should do that first, but there's nothing to simplify, so 0 is simplified. So that means I have 11 minus 3 times 0. 3 times 0 would go next. 3 times 0 is 0. 11 minus 0 would go last, giving me 11. And then finally on the last one, same process, but whenever we go through that process, we end up with 9. And so this is the term evaluate. It simply means that everywhere there used to be a function or an expression with a variable in it, the variable goes from unknown to something that is known. And then the evaluation is simply simplifying that new statement with y becoming 2, or y becoming 0, or y becoming 2/3. So notice that when we talk about from last time simplify, simplify just means to combine and reduce complexity. So the 3 times the 2 is an operation we can do. 3 times 2 is 6. The 11 minus 6 can be done as an algebraic operation, and 11 minus 6 is in fact 5. And so we've taken this complex statement containing two operations, a minus and a multiplication, as well as a set of parentheses, and reduce its complexity down to a 5. And it may feel like I'm over-explaining, but some people still don't get this. And so if this is easy, embrace that. Like it. It gets harder. Okay, so let's do the same thing with a different expression. I'm going to now do, let's see, 6 plus 2x minus 4y squared. Okay, so we're going to evaluate this thing. Now, when you evaluate, there's two ways you can evaluate. You can evaluate for a single unknown, like if I just said what happens if x is 4. What happens if y is -2? And there's also the possibility that when you evaluate, you could evaluate for both. What happens if x is 0 and y is 1? And so all three of these statements are just evaluations of my original algebraic expression. And so, just like before, evaluate means to plug in or substitute for an unknown. So I'm going to take this first one, and the unknown I'm substituting in is for x. So I'd have 6 plus 2 times 4 minus 4y squared. Now note, there are pieces of this that are not going to simplify because they don't simplify. A good rule of thumb in algebra is that variables and numbers do not interact directly. They are separate entities. Because a variable is an unknown, we do not know how it will act. And so we cannot actually do anything with the variable until it becomes a number, like it has here. So, what can be simplified? Well, first thing, add multiplication. The parenthesis has nothing inside of it to do, so I can ignore it. I can take this 2 times 4 as my next operation, giving me 6 plus 8 minus 4y squared. Now, what else can be done? I cannot combine the 4 and the 8 because it's not a 4, it's a 4y squared. It has a variable attached to it. This is now a coefficient, not a constant. Because of that, I can take 6 and 8 together to get 14. And because that y squared is there, that is the last step that I can do. I can combine constants with other constants. I can combine variables with the same variable, but I cannot combine cross-compatibility. To put it a very different way, you know, if you've ever baked a recipe, there are some substances that do not mix. Like if you try to mix them together, they won't, but others mix nicely. Like if you ever make eggs and you scramble them up, you know, and you put like a little butter or oil in the pan to keep it from sticking, the oil won't mix with the other two. And that's okay. It doesn't need to. It has its own separate job. The y doesn't mix with the 14 because they're separate functions or separate values. Okay? So we plug in the -2. So we take our function, 6 plus 2x minus 4, -2 squared. Okay. And again, I should make sure to do this properly. I do not have an equal sign, so I should keep it without an equal sign. All right. So 6 plus 2x does not do anything. It's 6, which is a constant. It's 2x, which is a variable with a coefficient. So I can't do anything here, but I can do stuff here. So let's isolate that piece. I have a -4, parentheses, -2 squared. So I do my order of operations. Let's start with what's in the parentheses, -2. There's nothing to do. So I now go under my next one, PEMDAS. So I go exponent, there's a square. Negative 2 squared makes this a positive 4. This becomes 6 plus 2x minus 4 times 4. Okay, at this point, I still can't do anything with the 6 and the 2x, so I cover those up. I have negative 4 times 4. Negative 4 times 4 is 16. And because it is a negative 4 times a positive 4, it would be negative 16. And then last of these, because there's still work that can be done, I cannot combine the 6 and the 2x, but I can combine the 6 and the negative 16. Notice how I can use here the associative property, which allows me to take these in any order that I want, because they're the same operation, plus and minus in this case being the same. So I can take the 6 and the 16 and put those together out of order, because the 2x in the middle doesn't do anything. So 6 minus 16 would become negative 10 plus 2x. And then my last one, same basic form. I take 6 plus 2 times 0 minus 4, 1 squared. Simplify what I can. Again, we do with what's in parentheses first. 1 is 1, 0 is 0, nothing to do. We do exponents next. 1 squared is 1. So I end up with 6 plus. So this becomes just 1. And we can now simplify. 2 times 0 is 0. Minus 4 times 1 is 4. And from there, we get the following solution. 6 plus 0 minus 4. Again, I can do it in any order. 6 minus 4 is 2, and the 0 doesn't do anything. My answer is 2. And so you can see when you evaluate, there are strict rules. But notice there's a theme that we talked about last time that cannot be overstated. The goal is, if we do this correctly, all of us should get the exact same solution. We should all have the exact same result when we are finished. If, for some reason, you did not get 14 minus 4y squared, if you did not get negative 10 plus 2x, if you did not get 2, there's a chance I made a mistake. Or there's a chance that you made a mistake. But one of us should be right if we are following order of operations correctly. Okay, let's get to the next piece. So we've talked about how to simplify functions involving numbers, or expressions involving numbers. Let's talk about how to simplify with variables in particular. I'm not going to lie to you. When I talk to most students, this is something that is struggled with at all levels. I see college students who make this mistake. I see high school students making mistakes. I see middle school students who are supposed to be, super smart. They make these mistakes all the time because it's just not the way we typically think. We typically like to think very straightforward, and algebra is more general. It likes to think of it as an abstract case. So let's look at 3 examples. I'm going to do A, B, and C. And we're going to talk through these as we go and discuss sort of how each of these pieces fits and see how to simplify them correctly. Now B, we got 2r minus 5, 3 minus r, plus 4. And we have 2mn minus 5m plus 3mn plus n. Okay, when simplifying. Now, it should be noted here that when we talk about simplifying, we've already discussed once the goal is to reduce complexity. But you can also think of simplify as what happens on one side of an equal sign. So you can simplify the left-hand side of an equal sign. You can simplify the right-hand side of an equal sign. You never cross an equal sign except via different rules, and that will be our last topic. And so if I ask you to simplify each of these functions, there are a few basic rules to follow. Rule number 1, you have to follow all of your properties. So last time we discussed 5 different properties. You have commutative, associative. You also have inverse, and identity. And then finally you have the distributive. Any of those 5 properties can be applied at any moment in time to these problems. Now, when I do some of these problems, you may see me take some steps in a weird way. That is because I will do them via these properties to showcase how they fit and how to do them with the properties. That doesn't mean this is probably how you think. You probably shortcut a lot of the math. And in many ways, that makes you very smart. But do note that does not mean that that's actually what you're doing. So let me showcase how this is done. Okay, let's take this first one, A. We have 3x minus 2y plus x minus 3y minus 7. For this problem, allow me to showcase the math of what to do in this problem. Step 1, the first thing I'm going to do is I'm going to use the associative property. What that means is I'm going to use the associative property to rearrange this function. I'm going to move the x's together, and I move the y's together, and the 7 I'm going to put off on its own, allowing me to rewrite the statement as follows. 3x plus x minus 2y minus 3y minus 7. Now, many of you guys have skipped this step because you're smart, and that's amazing. Do that, please. I'm showcasing how your brain does the math, because if you can understand how your brain thinks through the process, you can know when you make mistakes and how to fix them. So next step I will do is I'm actually going to use the distributive property. I do not expect you guys to follow this path. In fact, this path is crazy. Okay, just to be perfectly honest. This path is nuts. But this path does showcase why everything you've done for years works. Let's take a look now. If I distribute, and remember, there are 2 parts to distributive property. There's distributing into a parentheses and factoring back to a parentheses. There's 2 different ways to do it. So this one, I get x to come out, leaving behind a 3 and a 1. I get a y to come out, in this case a negative y to make it a little easier, leaving behind a 2 and a 3. Now, according to order of operations, I am always allowed to simplify, which I'm going to do, meaning I can reduce complexity in one piece or more than one piece of my function. So what am I going to simplify? I'm going to simplify what's inside of this parenthesis and what's inside of this parenthesis. Notice I can't do anything with the minus 7 because the minus 7 isn't in one of the parentheses, and according to order of operations, parentheses have to come first. So the x is 3 plus 1 is 4, the y, 2 plus 3 is 5, and the minus 7. Now, at this point in time, this is an acceptable answer in mathematical circles, but not one that we like, because we prefer to write it in a standard form. In case you're unaware, mathematicians typically like all terms. Remember, we have a term, we have a term, and we have a term. Remember, a term is anything separated by only addition or subtraction. So if you have something on the bottom of a fraction that has addition and subtraction, that's not a term because it's got a fraction and a plus, or a fraction and a minus. This means that there's only a plus sign between them or only a minus sign in between them. So this x times 4 is a term. This y times 5 is a term. This negative 7 is a term. Now, from here, it is common when it comes to terms that there is an order to them. The order is as follows, and I'll be brief with this. You have real numbers first. Then you have any symbols second. Symbols in this case would be like pi. Then you could have any radicals. Then variables. And then, as we'll eventually talk, imaginaries. So an appropriate list for a term would be like 4 pi square root of 7 xi. This is considered an appropriately named term. Yeah, it's got a lot of pieces, and most terms we're going to talk about aren't going to have all these pieces, but this is the order we would do them in. We have the real numbers first, any symbols like pi's or deltas or phi's are second, any radicals should come third, variables typically come last, although there is an argument to make them before the radical. And then imaginaries always come last because people hate imaginaries. We put them for last because we don't like them. Okay, over here. That means that x times 4 we could write as x4, but we don't like that. Y times 5 we could write as y5, and it's considered acceptable but not liked. Because it's possible for somebody to look at this and think it's x to the 4th power, y to the 5th power. And so here, we typically put the number first, the variable second. The number first, the variable second. And since there's only a number, just the number. So this is how we would algebraically simplify this expression involving variables. Now, many of you guys probably jumped straight from here to here without too much difficulty, but notice how to get there matches with the properties that we already know, right? We use the associative property to take the x's and put them together. If you didn't, you'd have to do 3x minus 2y, which doesn't do anything. You have to do 2y and x, which doesn't do anything. The associative property allows us to move pieces around so we can put them together. Notice how I used factoring, processed by the distributive property, in order to get the numbers to pop out, which explains why 3x plus x becomes 4x, not 3x squared, or some other random thing that some students write. There is a reason why this function becomes a 4x and not something else. It is because of the distributive property. Let's take a look at b. And I will do b the exact same way. 2r minus 5 times 3 minus r plus 4. Now, when you're doing a function, you can apply any property at any time. That is a big detail, because right now I have a 2r, a negative 5 times the parentheses, and a plus 4. There's nothing that can be combined because there's no way to simplify 2r and 5. There's no way to simplify 4 and this fraction because it doesn't work. Or sorry, this expression doesn't work. And so if we don't jump to distributive property, there's no way to simplify stuff. So I'm going to do that. So I'm going to distribute. So I have a 2r still. The 2r is just a 2r. I have a negative 5. Now remember, I like to do this by a very simple process. Whenever I multiply things, I like to do the symbols first and numbers second. So in other words, when I take this function and multiply them, I see a negative times a positive would make this negative. I take a 5 times 3 to get 15. I take a negative times a negative to make this positive. I take a 5 times r to get 5r. Doing it this way prevents any egregious mistakes, any randomness, okay? Because every time I ask, what's the symbol? Negative. What's the symbol? Positive. What's the number? 5. What's the number? 3. Negative times a positive makes it negative. 5 times 3 is 15. Negative times a negative makes it positive. It's a step-by-step process to guarantee I always get the answer right. And don't make any silly mistakes like dropping a negative sign, one of the most common mistakes in algebra. Or doing something random, like getting a function that doesn't work because you miss a symbol, or take 5 times 3 but not 5 times r. And so this helps prevent some of that. Next, I'm going to again use the associative property. The associative property allows me to move things around, provided they're all separated by the same symbols, and plus and minus are essentially the same symbol as long as the minus stays with the number. So I can move the 2r and the 5r together, just keeping the same symbols, positive 2r, positive 5r, and the negative 15 and the positive 4 I can move together using the associative property. Now, with those numbers, I can just simplify them. With these variables, I can use the distributive property again. So let's do it. So I factor an r out, leaving a 2 and a 5. With the numbers negative 15 and a positive 4 would make this negative 11. Now I can simplify again. actually going to write it in the correct form this time on the first try because I'm looking ahead. 2 plus 5 is 7, so I have 7r minus 11. Over here, in case you're wondering, this is the commutative property. Where the commutative property says I can switch the order of multiplication. So I take x times 4, I can also take 4 times x. This is also, just a nice thing to remember. So, anytime you're looking at these kinds of things, I'm not concerned if you memorize every single property. Heck, I don't have these properties memorized. I stopped referring to them within a week. But I don't let that stop me from doing the math right. Okay? If you are fully capable of every time starting here and ending here, I'm not worried. If you're fully capable of starting here and ending here every time, no mistakes, I'm not worried. But if you're making mistakes, it helps to take this slow, deliberate process. It's a pain, it's a lot of work, but it allows you to take those steps and get to a solution that you guarantee is right every time. All right, last one, and that's where we'll finish. I'm going to do it very quickly here. So let's look at C. So for C, we have 2mn minus 5m plus 3mn plus n. Step 1, I'm going to start skipping some of those steps so you can just see. For this first one, I'm going to use the associative again, which will give me 2mn plus 3mn minus 5m plus n. Notice that just like on the previous problem, parts may factor or distribute and parts may not factor or distribute. And so you have to be aware of those things. So now I'm going to distribute slash factor, allowing me to take an m and an n out of both pieces. Mn, 2 plus 3. There's nothing to factor out of these two, and so I'm going to leave them that way. Now from here, I'm going to simplify, and of course put it in the correct order. So 2 plus 3 is 5, so I'd have 5mn minus 5m plus n. Now you might look at this statement and say, well, I could factor out of these two terms. Could I simplify that way? Well, as it turns out, if you do it that way, you will eventually get back to a point where it's not easier, right? My goal with simplifying is to reduce complexity. I've done that. I've taken 4 terms and reduced them to 3 terms, each of which has the same variables in them. So I have a 5mn, I have a 5m, I have an n. Each term is unique. The goal of this process is when you are finished, you know something is simplified when you have unique terms. That's a big detail, is that my 5mn minus 5m plus n, those should all be unique, separate, different. That'll finish us up for today. I managed to finish out 2 minutes early, so that'll cut back some of the time I cut out from you guys yesterday. That'll be it though. I look forward to seeing you guys tomorrow. I'll post the time when we have our Zoom session later today when I get all the entries in that I can, and we'll have our first Zoom call tomorrow. I look forward to it, and I'll see you guys tomorrow.